All right, welcome. We are looking at day 2 of proving triangles congruent. So this is going to be very similar to what we did last time. We're just going to be kind of expanding it to look at 2 extra little rules that we can use to prove that our triangles are congruent. So last time we talked about side-side-side congruence, which means that all 3 sides of both triangles match, so the triangle must be congruent. We also said that if you know the angle between 2 sides matches the pair of sides in both triangles, then you have your side angle side congruence. So a new one we're going to add today is angle side angle, which means that we have a pair of congruent sides stuck between 2 sets of congruent angles. So if you notice, as we are looking at the markings on these triangles, over here they have an angle marked, over here they have a side marked, and over here they have an angle marked. So if I read that in order, it's angle, side, angle. So if we're looking at an example, we know that they're going to, give us our little given statement. So before we even do anything, we know that we're just going to put given in here. Then to figure out how the rest of this is going to go, we probably want to look at what information they gave us in the given statement. So we know that QS bisects PQR. So that means that this guy right here has to match this guy right here. So our next statement that we want to put up there is that angle PQS is congruent to angle RQS. And we know this because of the definition of angle bisector. Alright, so we look at it back and we see that we now have one congruent angle. They gave us in the given statement that angle PSQ is congruent to angle RSQ. So it looks like I've got a set of matching angles. So now all I need is a side that is in between those 2 angles. And so if we look, we notice that QS is actually in both triangles. So to solve this, we're just going to say that QS is congruent to QS. And we know that because of the reflexive property. And finally, if we have an angle marked over here, an angle marked over here, and the side in between them, that is our angle side angle congruence. So we can say ASA. That is our proof for example 1. All we need to do now is add in symbols. So these were angles. And there we go. Alright, so I will let you try guided practice number 1. Similar idea, just kind of go in and fill in the proof. Remember, you're looking for angle side. Alright, so the other thing that we're looking at is angle, angle, side. So notice this looks pretty much like the last one, only now the marked side is not in between the 2 marked angles. So in terms of how we set up the proof, it's going to be very similar because we're trying to find one set of matching sides and two sets of matching angles. Only the positions of the angles and sides are slightly different. So let's look at our example 2. So we are given that DAC is congruent to BEC down here. We know that DC equals BC, and we are trying to prove that ACD matches or is congruent to triangle ECB. So we look at that. We already have one set of angles marked. We have one set of sides marked. So in order to prove our triangle is congruent, we need at least one more set of angles. Looking at the picture, they didn't give us anything about angles D or B. So just like the first example we worked, we want to look for something that is shared in both triangles. And if you notice, this angle C right here got traced twice, right? When I traced out the red triangle and the green triangle, I had to make that angle C. So just like the first proof we did, we're going to end up using the reflexive property. So let's go ahead and fill in what we've said so far. As usual, the first statement was given to us. Like we said a moment ago, angle C is congruent to angle C by the reflexive property. And I know that this can be a little bit difficult to see as far as, which angles match up in their positions due to the fact that the two triangles are sort of stuck together. So what we want to do, if we're having trouble, is probably draw the triangles out separately. So I'm going to take the red triangle and draw it over here. I know I had a C here, an A here, and a D here. And now I'm going to draw the green triangle separate. I've got a C down here, I've got B up here, and D over here. And if I look at what was marked, we had angle C, and then we had a mark on angle A. That should have been an E. A mark on angle E, and then we said that CB was the same as CD. So if I look at it again, the positioning of my angles and my sides are such that I have an angle here, and a side here. Same thing over here, right? I've got an angle over here, an angle over here, and a side over here. So either way I look at it, this triangle has been proven congruent by angle, angle, side. Alright, so that is an angle, angle, side proof. Go ahead and try the next guided practice. Again, you're just going to sort of fill in the proof. We've got one more example for us to work today, and it's kind of a word problem. So we are working with a community service group to build a bridge. We notice that they've given us a pair of triangles, and they have told us that A is the midpoint of CD, and that DD is 15. Let's make that a little bit easier to see. There we go. Okay, so looking at the picture, we know that we have a pair of right angles that have to match because all right angles are congruent. We also know that angles BAC and EAD have to match because they're vertical angles. If we have a midpoint at A, that means that this part of the line and this part of the line are the same. So it looks like we actually do have congruent triangles based on angle side angle. Therefore, the distance from B to C must also be 15 because BC and DE are corresponding parts of congruent triangles. So since the bridge goes from point B to point C, that is the answer to our question. So we're just going to say that BC equals 15. And that is that. That's all I have for today. I will see you guys next time.